Hello everyone. Now we are going to say about the Routh Hurwirtz criterion. This is the method to find the stability of the system. Routh Hurwirtz criterion is used to determine system stability. Then it checks the stability without solving the characteristic equation, which is widely used in the control system analysis. The stability depends on the roots of characteristic equation. The characteristic equation is obtained from denominator of the transfer function. When the roots of the characteristic equation should lie on the left half of the S plane for stability conditions. If any one root of the characteristic equation may be present in the right half of S plane, then the system will be unstable. So this is the condition of stability of the system. So the concept of stability is, so when solving higher order equation which is difficult to analytically difficult to solve the higher order equations, but in Routh criteria provides an easier tabular method. It avoids direct root calculation. It is used to construct using coefficients of equations in Routh Hurwirtz criteria. So in Routh Hurwirtz criteria, Routh array is formed using the coefficients of equations. Rows are arranged in descending powers of S. Then elements are calculated using a specific formula. This is the concept of forming the Routh array using Routh Hurwirtz method. So then the system is stable if all first column elements of the Routh array are positive. There is no sign change indicates the stability. If the sign changes indicates number of unstable roots. That special case 0 in the first column, a 0 in the first column causes difficulty in calculation. It is replaced with small value epsilon. Then the stability is then determined by limit approach. So this is the concept of stability, finding the stable of the system using Routh Hurwirtz criteria. In special case, another special case is entire row will be 0. That occurs when symmetric root pairs exist. And then the auxiliary equation is formed from the previous row. Then differentiation helps to continue the array. Then a sample characteristic equation is taken. Then Routh array is constructed step by step. Then stability is checked using the sign changes as in the normal Routh array. So there are three cases in the Routh array. So first, just to summarize, so for the stable conditions, to find the stability of the system, we are taking the characteristic equation of the transfer function, that is denominator function of the transfer function. So from the characteristic equation, if the roots of the characteristic equations are present in the left half of the aspect, then the system is stable. If any one of the root characteristic equation may be present in right half, then the system may be unstable. Okay, so to find these things for the second order system, it may be complex. So using the Routh Hurwirtz criteria, there is a formation of Routh array. So using a simple calculation methods. So there is three cases in forming the Routh array. In first cases, normal Routh array. In second case, there will be one row full of 0. So for that auxiliary equation, we have to consider the auxiliary equation, then find the roots of the auxiliary equations, then proceed with the normal Routh array conditions. So in second case, the row full of 0 may indicate the roots may be present in the imaginary axis. This indicates that the system may be limitedly or marginally stable. Okay. The third case, the first element of the first column may be 0. So when it comes in this case, the calculation will be complex. So the 0 may be replaced with the epsilon, then proceed as in the normal case calculation, then find the stable conditions. Okay. This is a simple and a systematic method. No need to compute actual roots. Useful for higher order systems also. Does not give exact root values but applicable only for linear systems. Then it requires proper handling of special cases. So here the root array is shown with the example. So here the higher order indicates the first row, then a descending order will be formed. So in the first column of the root array, all the values should be positive and greater than 0. Then it indicates the system will be stable. If any one of the element may be 0, then it will be in the first column, it will be replaced with the epsilon. Okay, so if there is any sign changes in the first column of the element, that indicates the how many number of sign changes are there. That number of roots may be present in the right half of the S plane. That will indicate the system may be unstable. Okay, so this is the root theory conditions. Thank you.